This week we're going to learn a new equation for thermochemistry. It's the only equation you actually need for thermochemistry, and I'll write it in here. It's Q equals mc delta T. And we'll make a list over here of what all of those mean. Q, or I'll have to do it up here. Q is heat. I don't know why they chose Q, but there it is. M makes more sense. That's mass. C is a concept called specific heat capacity. And you'll see that in several of the videos that I've put in this lesson. It is a concept that relates how much heat a substance can absorb per gram per degree Celsius. So things like water have very high specific heat capacity. It takes a lot of energy to get them to change their temperature. Whereas things like metal, stone, rock, that sort of thing have very low specific heat capacities. So it doesn't take as much energy to raise their temperature. And then finally, we have delta T. Those of you might remember from math, delta means change. And so this is the change in temperature. And it's always going to be the final minus the initial. So let's do the first example together, and hopefully you can work through the other problems. It says the temperature of a piece of copper with a mass of 94.5 grams decreased from 48 degrees Celsius to 25 degrees Celsius as the metal releases 849 joules of heat. Is Q negative or positive? And what is the specific heat capacity of the copper? Because this problem says it releases that much heat, that means Q is negative 849 joules. If it absorbs that much energy, it is then positive. And those are the things about exothermic and endothermic that hopefully you learned last week. So we know that Q is negative 849 joules. We also know the mass of this piece of copper. It tells us it's 94.5 grams. And it tells us the initial temperature and the final temperature. So delta T, remember, is always going to be the final temperature minus the initial temperature. So in this case, the final temperature is 25 degrees Celsius, and the initial temperature was 48 degrees Celsius. And we can leave it in degrees Celsius because it's the difference in the two temperatures. And so it doesn't matter that it's Celsius. If it were Kelvin, we'd get the same delta T. So our delta T in this case is going to be negative 23 degrees Celsius. So now we're going to put all of that into our equation. Negative 849 joules